Did series sequences and series of functions and Vastus M test. Today we will be talking about a particular series of functions, and that particular series is known as power series. So what is a power series? A power series is an infinite series of functions of this form. Power series centered at z naught with a series of the form k equal to 0 for to infinity ak z minus z naught to power k. So this is the power series about z naught are centered at z naught. So this is a sequence, not sequence. This is a series of functions, but we are taking a particular type of functions here. And if you take z naught to be 0, then the power series is said to be series about origin. But usually when we will be doing analysis of power series, we will be taking series about 0 only. Why? Because if we make certain change, if we make change of variable, substituting z minus z naught by w, then the power series, the given power series, this above reduces to the case of power series about 0. Why? Because look at it. If you substitute w instead in place of z minus z naught, you will have a power series a k w to power k, and this is a power series about 0. So this doing making this change of variable is always possible. We can always make this change of possible just to avoid any mm, not to avoid anything. The results will be same for everywhere, but just to make it look simpler. So this is a power series. Okay. So for you, where AKs are coefficients, Z is a variable. Where AKs are constant coefficients, they are constant complex numbers. Only variable is Z here. So now the question of its convergence is an important thing, and it is to be investigated that where it is convergent, and the next result that is the main result of this power series and important result, it explains much about its convergence. So let me write first this result first. What it says that, so with this remark about that, we can make certain change of variable so that we can talk about power series about the 0. So we will be considering only power series about 0 whenever until it is specified that this power series about certain point. So let us consider this power series. Maybe during the lecture I may avoid certain time to write this range of this indices k, but it should be understood that it at most varies from 0 to infinity. So be a power series. Let this be a power series. This is just the hypothesis. So now look at the conclusion, how big this conclusion is and how strong this conclusion is this. Then there is an The real number, not real number, it can be extended real number. It can be any number from 0 to infinity. It can be infinity as well, such that this power series AK, ZK converges absolutely. It converges absolutely if mod Z is less than R and this power series does not converge if mod Z is greater than R. Not only this, you have another strong thing that is about this series is this uniform convergence on any closed disk inside this disk mod Z less than R. But it says that for each fixed R satisfying R less than R, this series, our series is uniformly convergent for mod Z less than or equal to R. So look at this, how strong this conclusion is. What it's saying, you just take a power series, then it says that there exists a number which can be zero, which can be anything from 0 to infinity. And you will see power series where this R is 0 and this R is infinity also. So it is not that they cannot assume 0 and it cannot be 0 and infinity. But so first look at this thing. There is a power series about origin. So what it says, you get a R, capital R, and in a disk of radius R, this one, in a disk of radius R, what it says that in a disk of radius R, this power series is convergent. Whereas here in this part, inside here, this is absolutely convergent. Power series is absolutely convergent. So then what it says that what it says about outside, it says that when you have a number here outside, what is outside? It says it is the outside of this disk mod Z greater than R. Outside, the series does not converge. Series does not converge. So this is the behavior that you are having a disk. R जब आपको मिला तो एक डिस्क मिल जाएगी आपके पास जिसका रेडियस आपके पास R है. तो उस डिस्क के अंदर आपके पास पावर सीरीज एब्सोल्युटली कन्वर्जेंट है. डिस्क के बाहर ये कन्वर्ज नहीं करती. और दूसरा, इसके अंदर कोई भी स्मॉल इसके रेडियस इससे कम ले लो, you take any smaller radius, और स्मॉलर रेडियस की कोई भी डिस्क ड्रा कर लो आप जो इस डिस्क के अंदर लाई करे, कैपिटल आर रेडियस की डिस्क के अंदर लाई करे, तो उस डिस्क के अंदर, स्मॉलर डिस्क के अंदर, इंडीड पूरी क्लोज डिस्क है ये, पूरी क्लोज डिस्क, ये स्मॉल आ रहा है यहाँ पर, पूरी क्लोज डिस्क के अंदर ये सीरीज नॉट ओनली एब्सोल्युटली कन्वर्जेंट है, ये यूनिफॉर्मली कन्वर्जेंट है, यूनिफॉर्मली कन्वर्जेंट है. सो ये देखिए जी, ये बिहेवियर है आपके पास पावर सीरीज का. जब आपको रेडियस ऑफ कन्वर्जेंस मिल जाता है, रेडियस ऑफ कन्वर्जेंस हर पावर सीरीज का होता है. अगर जीरो नहीं है तो हम इस तरह की डिस्क बनाते हैं, अगर जीरो है तो फिर तो ऑब्वियसली ये कहीं भी कन्वर्ज नहीं होगा, एक्सेप्ट z इक्वल टू जीरो पे ही कन्वर्जेंट होगी. अगर रेडियस ऑफ कन्वर्जेंस जीरो है, what is the radius of convergence? Like this capital R is actually called the radius of convergence. Let me call. तो ये देखिए, ये रीजन है. नाउ अब आपके पास एक इंपॉर्टेंट प्लेस बचती है जिसके बारे में मैंने कुछ नहीं बताया, वो है आपके पास बाउंड्री इसकी. बाउंड्री इसके, इस डिस्क की मॉड z इक्वल टू R. इस बाउंड्री के बारे में ये थ्योरम कुछ भी नहीं बताती है। इंडीड क्यों? क्योंकि बाउंड्री का बिहेवियर पावर सीरीज का अनसर्टन है। यहाँ हो सकता है कुछ पॉइंट्स पे आपकी पावर सीरीज कन्वर्ज करे और कुछ पॉइंट्स पे पावर सीरीज ना कन्वर्ज करे, बट एटलीस्ट इतनी गारंटी जरूर है, वो हम रिजल्ट नहीं करेंगे, बट यू कैन कीप इट इन माइंड कि ऑन दिस बाउंड्री ऑफ दिस circle of radius r, there will be at least one point where this power series will not be convergent. ठीक है, तो यहाँ हम कुछ नहीं कह सकते हैं जी, cannot say anything here, cannot say anything certain with certainty, क्योंकि यहाँ ये कन्वर्ज भी हो सकती है और डाइवर्जेंट भी हो सकती है कुछ पॉइंट्स पे। तो ये बिहेवियर है आपके पास पावर सीरीज का। ठीक है, तो ये जो आर आपके पास है, अब ये आर एक इंपॉर्टेंट नंबर बन जाता है, तो इस आर का जो नाम दिया जाता है, इस आर को हम बोलते हैं रेडियस ऑफ कन्वर्जेंस, रेडियस ऑफ कन्वर्जेंस। और इस आर रेडियस की जब हम डिस्क लेते हैं, ये जो डिस्क बनती है आपके पास रेडियस, क्योंकि पावर सीरीज अगर अबाउट ओरिजिन के है तो 0 सेंटर आएगा, और रेडियस आर, ये जो डिस्क मैंने फॉर्म करी हुई है, let me color it, this one, this whole disk, ये जो डिस्क है, this disk is called disk of convergence, this is called disk of convergence, this may be called disk of convergence. Okay, so this is when the disk of convergence, when the power series is about 0. So when the power series, if you consider general power series, if you have power series about, for example, if you consider general power series about any point z minus z naught to power k, तो स्टिल आपके पास ये वैलिड हो गया थ्योरम, उसमें कोई चेंज नहीं आएगा। द ओनली थिंग इज दैट उसमें जो डिस्क होगी, डिस्क विल बी z माइनस z नॉट लेस देन r, तो उसमें जो डिस्क होगी दैट विल बी सेंटर्ड एट z नॉट, डिस्क का सेंटर z नॉट होगा और रेडियस आपके पास r होगा। तो बिहेवियर वही होगा कि डिस्क ऑफ कन्वर्जेंस के अंदर सीरीज एब्सोल्युटली कन्वर्ज करती है, बाहर आपके पास डाइवर्ज करती है, बाउंड्री पे कोई बिहेवियर उसका मालूम नहीं है। और डिस्क ऑफ कन्वर्जेंस के अंदर कोई भी स्मॉलर डिस्क अगर आप ले लोगे, क्लोज डिस्क स्मॉलर ले लोगे, तो उस क्लोज डिस्क के अंदर आपके पास पावर सीरीज यूनिफॉर्मली कन्वर्जेंट है। So this is all about this theorem says, but let us see now its proof, and it is an important also to know how to find the radius of convergence. I will tell some of the techniques, some of the formulas will be brought to your notice, which helps you to compute the radius of convergence of a given power series. So let me begin the proof. The proof is, first we have to find that R, जिसके बारे में बात हुई है, R होना चाहिए एक, तो let me define that R. Let कैपिटल R मैं डिफाइन कर रहा हूँ, आपके पास ध्यान रहे ये पावर सीरीज है, मैं ये कोफिशिएंट्स एक केस यूज करूंगा। दिस इज द पावर सीरीज, आई एम डिफाइनिंग इट टू बी सुप्रीमम ऑफ all those non-negative real numbers are for which this sequence, ये कोफिशिएंट्स की सीक्वेंस मॉडुलस में लो और r की पावर k करो, is bounded. This is the definition of this radius of convergence, and we will actually prove that this is the number which satisfies all the conclusion that has been asserted in the theorem. So this is the supremum. Now clearly r cannot be negative, so r has to be anything greater than or equal to, but r can be infinity as well. There is nothing which bounds this, which makes it less than infinity. So now let me make an observation first, and that observation will be used This observation will be used in completion of this proof. What it says that if this sequence is bounded for some R naught, then it is bounded for any R lying between R naught. अगर R naught के लिए ये बाउंडेड है तो R naught से लेस जितने भी नेगेटिव R होंगे उनके लिए भी ये बाउंडेड होगा. वो क्यों? क्योंकि देखिएगा why? बिकॉज आपके पास R naught के लिए ये बाउंडेड है, मतलब आपके पास A के R naught to power K जो है दिस इज लेस देन और इक्वल टू सम कांस्टेंट M, बाउंडेडनेस है. एंड R लेस देन R naught का मतलब है कि आपके पास R to power K is less than R naught, और मल्टीप्लाई सेम कांस्टेंट से करो तो इट सेज दैट A के R to power K is less than, or you can at most write less than or equal to mod A K R naught to power K, but this thing is less than or equal to M. What you get then? You get that A K R to power K is less than or equal to M. So it also becomes a bounded sequence. So this is the observation that if it is bounded at a certain R, then it is bounded for every R less than that particular choice of R. So this is the R, capital R ka definition and this observation. Now let us look, try to prove all those things. And now let mod Z be less than or equal to R, where I am choosing this small r to be anything less than capital R. Okay, I am choosing this to be anything less than capital R. So now small r and capital R are two real numbers, and small r is strictly less than R, and these are two different real numbers. So I can choose the third real number between these two. So I can choose another real number S such that R less than S less than R. Okay, I can choose always a real number between R and capital R. Now, since this S is strictly less than R, so by definition of R, क्योंकि कैपिटल R is supremum, so this और अभी ऑब्जर्वेशन यूज करी तो सुप्रीमम से पीछे अगर ये नंबर तो कैपिटल इस S के ऊपर भी वो सीक्वेंस कन्वर्जेंट होगी. ये सॉरी कन्वर्जेंट नहीं, it will be bounded. We see that this sequence AK S power K is bounded. Say AK मान लेते हैं ये bounded by M है. Suppose it is bounded by M. Now for mod Z less than or equal to R, I'm taking the smaller disk. This is the radius of convergence, and I'm taking this is the disk of convergence, and I'm taking a smaller disk now. I'm taking this smaller disk. On this smaller disk, let us look at this these numbers AK Z to power K, and let me tell you what I am intending to show here. I am intending to show here that for this Z, this power series is uniformly convergent, and to show this I want to show this is my desire. It's uniformly convergent, and what tool I'm going to use to do this thing is I'm going to use Vastus M Test and see how Vastus M Test will come in play here. This is something that is my intention here. This is my intention, and this is something that I will prove. Now let us look at this thing. Vastus M Test, what it says that in Vastus M Test, the terms of the series needs to be bounded by some non-negative numbers, and the corresponding series of those non-negative numbers needs to be convergent. So here first we need to find those non-negative numbers first. So I can write this to be, since this is mod of z is less than or equal to r, so I can write it as to be mod a k and r to power k. Here I'm going to make certain change. Here I'm going to write it as a k s power k times r upon s power k. Okay, and corresponding to this, as this series is this sequence is bounded, so it comes to be less than or equal to m times r upon s power k. So let me put here mk to be this m times r upon s to power k. This is the number. Then clearly look at this thing. These mk's are non-negative number, and the series this mk are positive numbers, which is summation m r upon s k, which can be written as m times summation r upon s power k. And look, this summation is now is a geometric series. This is a geometric series whose common ratio is r upon s, and this is less than 1. Why it is less than 1? Because r is strictly less than s. R is strictly less than s. Look at here. So when the common ratio is less than 1, the geometric series is convergent, and hence this is convergent. So this is convergent. So now looking at comparing these two series, this is what I did. This is the series, and this is a series of functions, and another series I have this series of numbers, and each term or each function of this series is less than or equal to the term of corresponding term of this series, and this series is convergent. So now Vastus M Test says that this series of functions has to be uniformly convergent. So therefore I must say now by Vastus M Test, therefore by Vastus M Test, we see that this series AKZ is uniformly convergent on this closed disk. This is uniformly convergent on this closed disk. And let's look at, so one, you got this expression to you know, whatever z you take, and you fix the radius of some number, smaller radius, and inside that the series is going to be always uniformly convergent wherever you fix this z. So you want to show this to be absolutely convergent, and it follows from this expression why it is absolutely convergent. Absolutely convergence means you have to show for every z it is pointwise convergent, means kind of this thing you have to show that this thing a k z to power k is pointwise convergent. So how it follows from here, if you take any z in this disk of convergence, let us look that you take any z here, and what you can do then, you can draw a circle which touches it, but since you are taking this z, yeah, you can draw another larger radius, larger circle. Why? Because you are taking mod z to be strictly less than r, and you can always find another number between mod z and r, so that it becomes a larger radius s, and then this what I just proved is that this series is uniformly convergent for mod z less than or equal to s, and if it is convergent for this series, it covers this z which comes now inside of this circle, middle circle of this. So that means this series is absolutely convergent. Also, it follows from this uniform convergence. Now only it remains to show that when z is outside of, when z is here outside of this disk, then this series is divergent. So what is the how we are going to show that this series is divergent? So let me first take, let mod z be greater than r, and let r से denote करो mod z को, and this is greater than r. ठीक है? Then by definition of capital R, this sequence ak r to power k is not bounded. This is not bounded because what is the definition of, if you remember, look at this definition of capital R. Here is this definition of capital R. It is the supremum of all those R for which this sequence is convergent. So that means if you choose any R which is bigger than this R, for that the sequence will not be bounded. If it is not bounded, that means it is an unbounded. That means that is there exists a subsequence of this sequence ak akj rkj such that it goes to infinity. It goes to infinity. So this means that it implies that this limit of this sequence r to power k goes to infinity is not equal to 0. ये तो क्लियर हो गया. अब देखिएगा अगर आपके पास एक एसेंशियल कंडीशन होती है, एक नेसेसरी कंडीशन होती है कन्वर्जेंट सीरीज की, कि अगर आपके पास कोई सीरीज है, अगर ये कन्वर्जेंट है, if this series is convergent, फिर इसकी एक नेसेसरी कंडीशन होती है, इसकी nth टर्म्स का जो लिमिट होता है इट गोज टू 0. तो अब हमें यहाँ क्या मिला? आपके पास हमें यहाँ मिला कि हमारी जो सीरीज है, सीरीज की जो ये nth या kth टर्म जो भी है, लेट इट बी k, इसकी kth टर्म 0 को अप्रोच नहीं करती है. इसकी kth टर्म 0 को अप्रोच नहीं करती है, इसका मतलब ये जो सीरीज है ak r to power k, this series is not convergent. This series is not convergent. So rk क्या? rk is your it is not convergent means this implies that ak z to power k is not convergent for mod z greater than r. So this is it, and it completes the proof. Do you have any question? Please ask. Before I move on, just tell me if you have any query. बोलो जी, है कोई क्वेश्चन? Anyways, can you hear me? Are you hearing me? Are you listening to me?
Yes.
Okay. So This is about the convergence of power series and existence of the radius of convergence. And now I'm going to give you two formulas, or they are also called tests of. Uh, I will call them the formulas to calculate the radius of convergence of a power series. One is inspired from the ratio test. आपको मालूम है रेशियो टेस्ट, रूट टेस्ट आपने पढ़े हैं, तो उन्हीं से ये हम एक रिजल्ट ले लेंगे. I will call it as a theorem. We have if this ratio modulus has a limit L, but what we want to show that L can be anything. L can be, it can be finite as well as infinite. We hardly worry about it. Can be infinity as well. So finite or infinite, बस limit होनी चाहिए. Then the radius of convergence of this power series, ये इस power series के coefficients का ratio लिखा है मैंने इधर, z minus z naught to power k, and the radius of convergence of this power series is this limit. अगर इसका लिमिट एग्जिस्ट करता है, कुछ भी है, वो फाइनाइट है या इन्फिनाइट है या जीरो है, नेगेटिव तो ये होगा नहीं क्योंकि मॉडुलस में ले रहे हैं, तो ये रेडियस ऑफ कन्वर्जेंस है. ठीक है जी. तो लेट मी गिव अ वेरी ब्रीफ प्रूफ टू राइट. इट्स वेरी शॉर्ट प्रूफ कि कैसे आपके पास होगा. तो लेट अस राइट कि इसकी लिमिट का वैल्यू रखते हैं. लेट इट बी let this be. Okay, so now what we want to show that L is the radius of convergence. Now if R is less than L, you choose any number less than, then डेफिनेशन के अकॉर्डिंग, डेफिनेशन लगाओ इसके ऊपर, लिमिट की डेफिनेशन लगाओ, तो आई कैन चूज सम n greater than 0 such that I can make this number ak upon ak plus 1 to be greater than R for all k greater than or equal to n. This is the definition. This follows from the definition. Its limit is L. And what it implies that mod of ak is greater than R times mod of ak plus 1. And this is true for every k greater than or equal to n. तो अब आप इसको k की वैल्यू सब्स्टिट्यूट करते जाओ ना, n से लेकर a, आपके पास क्या बनेगा? आपके पास आ जाएगा a n r टू पावर n. a n पे यूज करोगे तो इट विल बी ग्रेटर देन और इक्वल टू a n प्लस 1. इनइक्वालिटी है टाइम्स r है, तो r टू पावर n ऑलरेडी है, तो r टू पावर n प्लस 1 हो जाएगा. फिर वो इनइक्वालिटी इस पे यूज करोगे तो यू विल गेट a n प्लस 2 r टू पावर n प्लस 2 हो जाएगी, ग्रेटर देन सो ऑन. सो व्हाट इट इंप्लाइज दैट ये डिक्रीजिंग सीक्वेंस बन रही है, इसका ये काइंड ऑफ बाउंड बन रहा है. तो इंप्लाइज दैट वो फाइनाइटली मेनी टर्म्स को छोड़ के ये पूरी सीक्वेंस जो आपके पास बन रही है ए के आर टू पावर के जो है के ग्रेटर देन इक्वल टू एन के लिए बाउंडेड है. तो पीछे फाइनाइटली मेनी टर्म्स ही बचे हैं, तो वो फाइनाइटली मेनी टर्म्स भी बाउंडेड ही होंगी, क्योंकि फाइनाइट टर्म्स तो बाउंडेड ही होंगी. तो यू कैन से दैट दिस सीक्वेंस इज बाउंडेड. तो therefore by definition of capital R, रेडियस ऑफ कन्वर्जेंस की डेफिनेशन के अकॉर्डिंग जिसके लिए ये सीरीज सीक्वेंस बाउंडेड होती है, तो वो R जो होता है दैट हैज टू बी लेस देन और इक्वल टू R. अब क्या था, सिंस R less than capital L was आर्बिट्रेरी, ये आर्बिट्रेरी नंबर था लेस देन एल, और हमें क्या मिला कि दिस नंबर इज लेस देन आर। तो इसका मतलब क्या हो जाता है, इट फॉलोज दैट दिस कैपिटल एल इज आल्सो लेस देन इक्वल टू आर। लेकिन हमें कैपिटल एल को इक्वल टू आर शो करना है, रेडियस ऑफ कन्वर्जेंस के बराबर शो करना है। तो ये हो गया एल लेस देन इक्वल टू आर। नाउ वी हैव टू शो दैट आर लेस देन इक्वल टू एल, सो दैट एल इक्वल्स टू आर हो जाएगा आपके पास। सो on the other hand, suppose next we suppose that s is some number which is greater than L, and I will show that this s is greater than or equal to R also, so that L will be greater than or equal to R. Then again फिर से definition लगाएगा, then again by definition of limit I can have this expression ak upon ak plus 1, and now it will be less than s because I can make it to be less than L, and it will be less than s also for all k greater than or equal to n, or I can say that then there exists some n greater than 0 such that you will have this thing. और यहाँ से आपके पास क्या बनेगा, यहाँ से आपके पास ये बनेगा ak less than s times ak plus 1 for every k bigger than or equal to n. And now if you employ this inequality, by substituting k equals to n and n plus 1, let us me first write a n s to power n. अब a n पे लगाऊंगा तो it has to be less than or equal to a n plus 1 into s, और s already यहाँ पर s to power n है तो it will be s n plus 1. फिर a n plus 1 पे लगाऊंगा तो it has to be a n plus 2, and it will be s to power s, और s to power n plus 1 already है तो it will be n s n plus 2, so on. इस तरीके से तो इसका मतलब ये काइंड ऑफ इंक्रीजिंग टर्म्स बन रही हैं। तो इसका मतलब द टर्म्स a k s to power k does not converge to zero. That is, this implies that is for mod z equals to s, ak z to power k do not converge to zero. अगर ये टर्म जीरो को नहीं कन्वर्ज करती है तो इसका मतलब आपके पास जो ये पावर सीरीज है a to power z k है, this is not convergent, this is not absolutely convergent. अगर ये absolutely convergent नहीं है तो इसका मतलब आपके पास जो s है, s has to be bigger than radius of convergence, क्योंकि if it would have been less than radius of convergence, अगर ये लेस देन रेडियस ऑफ कन्वर्जेंस होता आपके पास तो फिर तो पावर सीरीज कन्वर्जेंट होती ना, लेकिन ये ग्रेटर देन और इक्वल टू आर ही होगा, तो दैट्स व्हाई दिस इज नॉट अ कन्वर्जेंट. तो सिंस अगेन वही आर्गुमेंट आएगा आपके पास कि एस वाज arbitrary greater than or equal to L and it becomes greater than or equal to R, and this implies that L is greater than or equal to R. So with this inequality we had already shown that R is greater than or equal to L. We get that hence we conclude that L is equal to radius of convergence. ठीक है जी. तो ये है. तो नेक्स्ट जो टेस्ट है, नेक्स्ट इज अ रूट टेस्ट. रूट टेस्ट का प्रूफ भी आप एग्जैक्टली ऐसे ही फॉलो करेंगे, वो और भी छोटा है इससे, उसमें ज्यादा कोई दिक्कत नहीं है. आप कैमलिन की बुक से उसको देख सकते हैं. दैट इज मच सिंपलर एंड दैट डजंट रिक्वायर एनीथिंग एक्स्ट्रा देयर. So, but I will state that here for your reference. What it says that if this limit root of mod of ak exists फिर अगेन यहाँ हमें वही लिखना है कि इट कैन बी फाइनाइट और इनफाइनाइट, बस ये एग्जिस्ट करने चाहिए, फाइनाइट हो या इनफाइनाइट, देन the radius of convergence of this power series ak z minus z naught to power k is, इस केस में थोड़ा सा आपको ध्यान रखना, इसमें रेसिप्रोकल होता है जिस लिमिट का, इट हैज टू बी रेसिप्रोकल ऑफ दिस लिमिट. It has to be reciprocal of this limit. So let me consider a power series now, where we will employ this both these tests. This second one you may call it as root test also, and इसको root test. पहले वाले को आप रेशो टेस्ट बोल सकते हैं, यू कैन कॉल इट रूट टेस्ट. रेफर करते समय हम रूट या रेशो टेस्ट ही रेफर करेंगे. So let's consider this power series now, and let's try to find its radius of convergence. Let me consider example. Consider this power series k z to power k, and then let us. I will apply here the ratio test. By ratio test, I have to find this limit ak upon ak plus 1 modulus. But first this ratio, what is ak? Ak is k. Ak plus 1 will be k plus 1. Looking at the ak's coefficients of this z to power k. So this limit, if you compute this limit is nothing but this limit is 1 as k goes to infinity. So what it implies, so by ratio test, if this limit exists, then the value of this limit is nothing but radius of convergence. That means r is equal to 1. So radius of convergence of this power series is 1. What it is radius of convergence? That is this power series k times z to power k is absolutely convergent for any mod z less than 1. ये इसका radius of convergence है. And let me illustrate the use of root test also. So root test के लिए I am considering another power series 2 to power k z to power k. So here let me employ root test. By root test आपके पास ये numbers तो पहले calculate करने हैं आपको, a k modulus. So what is ak? Ak is 2 to power k. So this is actually 2 to power k to power 1 by k, and it is 2. तो ये लिमिट भी इसका 2 ही होगा. This implies that limit k ak is nothing but 2, क्योंकि 2 तो कांस्टेंट है. तो अगर लिमिट 2 है तो इसका मतलब रेशो टेस्ट क्या होता है? देयरफॉर रेशो टेस्ट के रूट टेस्ट के अकॉर्डिंग रेडियस ऑफ कन्वर्जेंस हैज टू बी रेसिप्रोकल ऑफ दिस लिमिट. तो रेसिप्रोकल इसका बनेगा 1 by 2. So this power series has radius of convergence 1 by 2. Is it okay?
Yes, sir.
And now finally, if you fail to find the limit by either by root test or ratio test, because there might be sometimes there might be a possibility, and there might be some power series for which you may not be able to compute this limit. जरूरी नहीं कि ये रेशो या रूट टेस्ट की लिमिट, क्योंकि उन पे कंडीशन है कि अगर वो लिमिट एग्जिस्ट करे तो फिर आपका रेडियस ऑफ कन्वर्जेंस वो लिमिट्स की वैल्यू या रेसिप्रोकल ऑफ उसका हो जो उस लिमिट की वैल्यू का हो जाता है. Otherwise, there is another standard formula which is known by after two famous mathematicians, Cauchy and Hadamard. Hadamard formula. And I'm not going to write the proof of this. For that, you need a and you need to be handy with the limit superior and limit inferior. and for that case the radius of convergence of any power series, radius of convergence of the whatever power series you take, यहाँ कोई condition नहीं है लिमिट एग्जिस्ट करनी चाहिए या नहीं करनी चाहिए, it is convergence R is R equals to 1, ये लिमिट रूट टेस्ट से ही डिराइव हो जाती है, बट यहाँ लिमिट सुपीरियर है जी, ठीक है जी, आपको लिमिट इंफीरियर और लिमिट सुपीरियर का कॉन्सेप्ट होगा तो यू कैन अंडरस्टैंड इट फ्रॉम देयर। तो उस केस में ये एक फॉर्मूला होता है, तो जहां पर आपके पास ये लिमिट्स एग्जिस्ट करती हैं तो वहां लिमिट सुपीरियर लिमिट के बराबर ही आता है, ठीक है जी। तो उस केस में आपके पास ये जनरल फॉर्मूला है, वो अगर आपसे नहीं कंप्यूट होती यू जस्ट यूज द लिमिट्स यू कंप्यूट थ्रू, एंड ये डेफिनेट है, ये कंप्यूट होगा ही होगा, चाहे इसका वैल्यू 0 आए या कुछ भी आए, 0 और इन्फिनिटी के बीच में, तो ये आपके पास हमेशा ही होगा। सो इफ यू हैव एनी क्वेश्चन यू कैन आस्क मी, डू यू हैव एनी क्वेश्चन? Are you hearing me, listening me?
Yes, sir.